Okay, so thank you, Gabriel. Hello to everybody. My name is Samuel Martin. I'm doing this presentation remotely because unfortunately I'm off sick under medical leave, so I've not been able to join the meeting at CEA premises. But I hope to be able to provide a good presentation anyway and to convey the messages that I would like to give you all. So thank you all for attending this forum. Thank you, CEA, for hosting it, and to Eclipse for the remote session. Before starting with the presentation, I'd like to introduce myself. As you cannot see me, just that you can put a face to my name. I'm Samuel Martin. This is my email address, ys.martin@upm.es. I'm currently the scientific and technical lead of the Horizon 2020 PDP4E project. I've been working previously in a bunch of other European projects since the 6th framework program, and I have a position as a researcher at the Universidad Politecnica de Madrid, Technical University of Madrid, concretely at the Department of Telematics Systems Engineering. So just to let you know a bit about myself and imagine who is at the other side of the screen. So in this presentation, I'm going to go through the different parts of PDP4E, provide an overview, and it's structured into this section. First, I will provide the motivation, which is the problem that we are addressing, which is the challenge that needs to be solved, and how PDP4E is providing a response to the challenge. Then I will explain the conceptual approach that we have in PDP4E, going forward with the contributions from the different disciplines that were already mentioned by Antonio, and which are tackled by the PDP4E methods and tools. And finally, I'll try to provide an overview of how everything fits together in an overall method, and what's the rationale for all these things that we are doing. So, just as an introduction, if you've traveled through relevant airports, let's say, in recent months, you may have had the chance to encounter these ads by Google in Washington, D.C., in Brussels, in large, let's say, bureaucratic capitals, where basically what they are doing is advertising their privacy features. Google advertising privacy features. Come on. This means something. This means that privacy and data protection is something which is trendy, up to the point that Google is emphasizing that, hey, we take into account, we take care of your privacy. And again, I emphasize Google. So it's one of the largest companies, and they are in the ICT sector, and they are not emphasizing the new feature of Maps, YouTube, or Android, but privacy. And this is because people are claiming Google to respect their privacy. So if privacy and data protection are so trendy, then we may wonder whether it's an issue to engineers or not. And the answer is that it seems it is indeed an issue to engineers. These are screen captures of these are screen captures. There's a bit of echo, sorry. From different blogs, magazines, journals, etc., which are targeting engineers. And in summary, you may just realize that they say that engineers need to be involved in the loop. This is not something that is just something for lawyers or for managers, but even individual coders will need to take into account the General Data Protection Regulation, which is the European Union regulation dealing with this privacy and data protection aspect. So then, if engineers need to be or must be involved in the loop, then the question is, are there tools for them, or which are the tools that they may encounter that they can use to address these issues? Well, currently there's a gap between what engineers need and what engineers get. What engineers get can be summarized into these four alternatives. There's the law, the thick, big book of the law, the GDPR and other regulations that are out there, which are great, but they are written in legal language, and they are targeting legal experts or legal people. They are not using engineering language, they are not using engineering structure, and they, in summary, are not, they don't go into the details also that are needed for engineering, because that's not the role of a law. A law doesn't tell you how you should do the things. It only provides you with obligations that you must abide by, but then you are free to implement them as you wish or as the state of the art allows you to do so. So, okay, there's the law, which is good because it establishes rights, freedoms, obligations, but not so good because it's not targeting engineers. There's also a set of principles which are summarized into the privacy by design approach, which basically tells you to tell system designers, systems engineers to introduce privacy since the onset, not as an afterthought, so that it's taken into account throughout the lifetime of the project, and following some principles such as win-win, be proactive, not reactive. Okay, those principles are great, but this is that they're not operationalized. In fact, it risks becoming, privacy by design risks becoming a bare principle without any real impact, or even being voided of its content just as a fashionable term, which is subject to, let's say, false claims like pretenders that say, oh, we do privacy by design, but then there's nothing behind that facade. And that's because it's just a set of principles, it's a set of aspirational principles you should try to aspire to, but you cannot claim compliance with directly because they are not operational. Okay, but there are technical solutions for privacy. Yes, there are. Privacy enhancing technologies, as they are called, PETs, they are technical solutions, but they are still, many of them, in the state of the art, and they lack a systematic guidance for application, which allows an engineer, when they are facing a common problem, decide which privacy enhancing technologies they should apply, how they should apply them, a kind of drag and drop that they could use. And then finally, there are some tools for privacy management, such as privacy program management or privacy enterprise management tools. But again, they are not targeting engineers in the systems development lifecycle process. Sometimes they are addressing IT managers, others they are targeting managers in general, and they are not privacy savvy, but these tools do not integrate within the systems development lifecycle. So what engineers need, it's not regulation, it's not principles, it's not craftsmanship of the technologies they need to apply once or just once. It's not just management. They need engineering methods and tools. They need things such as this, which appear to the right. These are captures, indeed, of the background tools that we use in our project. Engineers need backlog items. Engineers need deployment models. Engineers need data flows. Engineers need engineering tools. So this may sound quite logical, quite reasonable, and that's why we created this project. This is the answer that we provide to this gap. We want to endow engineers with privacy and data protection tools that are aligned to their mindset. How we do that, as Antonio already advanced, what we do is to depart from the background, the landscape of software and systems engineering disciplines, where there's a large established body of knowledge, and we introduce existing privacy and data protection methods. We have not invented them. They existed in the state of the art in previous academic and research works, and we create privacy and data protection engineering methods and tools which allow engineers to reuse their background in software and systems engineering, but introducing privacy and data protection aspects in a smooth and seamless way, or at least smoother than what might happen if just trying to use the method from scratch. As a result of this project, we provide a set of software tools, sure, but these tools are not there in isolation. They are supporting some methods which introduce different privacy and data protection activities through the life cycle. Then some knowledge bases which are reusable, for instance, basis of patterns, basis of threads. And then we are indeed applying this to different scenarios, different use cases, for which we will build demonstrators. And we are also creating a community, of which this forum is one of the events for the creation of the community. We are also disseminating the results as open source, disseminating in IPEN. Well, we want to reach the outside, not just get into the results, technical results of the project. In particular, we are doing that by addressing 4 different disciplines which we consider to be key in software and systems engineering and in privacy engineering in particular, which are requirements engineering, risk management, model-driven design, assurance, and which I will detail later. Then to the left, we have the supporting products, and to the right, we have the demonstrators that I mentioned. And just I would like to quickly show the different tools and methods that we are supporting in this project. You may see there are 2 large tools, 2 large background tools, which are Papyrus and OpenCert, which are not privacy engineering tools. They are software engineering, systems engineering tools in general, addressing requirements engineering, model-driven design, assurance, which have been previously used. We also have Primacy, which is used for code validation, and we also have Musa, which is a tool for risk management. Then we have a set of background methods. For instance, here we have UML4PF, ProPAM, Prepare, Lindun, which were already mentioned before, and which have privacy background methods, and which we integrate into these tools to achieve these privacy and data protection engineering methods and tools. Okay, so that's it. And before going into the specific contributions, just pay attention to this slide because this clarifies some concepts which are relevant to privacy and data protection. So shake your head and get rid of any prejudice that you may have regarding privacy and data protection, because there are some concepts which sometimes are not completely right in common parlance. So privacy is not secrecy, privacy is not confidentiality, privacy is not security. If you ask me what privacy is, well, maybe I could give you many answers, as many as authors that there are, but there are some common traits. So take this into account. Privacy means personal data. If there's no personal data there, then it's not privacy, it's something different. If you are just assuring corporate data, for instance, it's not privacy. But personal data is anything that can be related to an individual. So if you get a call record, for instance, that's personal data because it's linked to a subscriber. If you got an energy consumption record, that's personal data because it's linked to a subscriber. It's an individual person. Privacy is more than security. For sure, security is needed to get privacy. So traditional security, properties, confidentiality, nobody can access a piece of information at rest or in transit unless they are authorized to do so. Integrity, information cannot be changed. Availability, it's information or a service is available, they're relevant. But there are other privacy properties which are privacy specific. I wouldn't go into detail, but just to mention, for instance, unlinkability. If you have a piece of data which is not related to a person, but can be related through inference, etc., then there's a privacy issue. And this is not related to confidentiality. You can have the same data set with strict access controls, but you have the chance, or there's a possibility that this can be linked. Then transparency, being able to demonstrate or to show what's being done with personal data and transmit that to the data subject, to the person involved. Intervenability. So, in summary, privacy goes beyond security. Do not think of privacy just as privacy is the same as security with personal data. No, there are more things like that, more things beyond that. Think in terms of what I could infer if I have this personal data. This is privacy. Could I de-anonymize an individual from a data set? This is privacy. All those are privacy issues. And in fact, there are some privacy strategies which are not typical from security, but which appear in the case of privacy. For instance, abstraction. Instead of providing a detailed location, you provide a less granular location, an aggregate location, or an aggregate consumption of a service, of a smart grid service during a whole month. This is abstraction, and this is not something that would be usually done with security. There are also some privacy principles. There are a lot of principles in both ISO 29100 and GDPR, but just again to let you realize this is more than security. Consent is not security. Consent means that free and informed consent means that the data subject is aware of what is being done with the personal data and consent for that use, and specifically for that use and not a different purpose. Again, this is not typical in security. Well, I just mentioned the purpose, lawfulness and legitimacy. Then there are several aspects introduced by GDPR regarding data subject rights and regarding legal obligations of controls and processors. For instance, the infamous right to be forgotten, right to erasure, right to information, right to data portability. All these appear in GDPR and go beyond what would be expected if we are talking about just security. So just in summary, realize that privacy and data protection involve a set of concepts. Maybe some of you were already familiar with them. Maybe others are not, but just keep this in mind during the whole day, because we are doing more than just security with personal data. And when we are talking about privacy and data protection for engineers, we mean that we want to provide these tools, but not tools that require ad hoc work, but systematic, economical engineering methods and tools. We want to lower the barrier to entry to privacy engineering, so that engineers need not be privacy savvy to be able to make their systems be privacy compliant. And indeed, we do this by encapsulating all the privacy savvy into the tool. And for sure, it will depend on the specific engineer, on the methodology they are using, on their level of expertise. But in principle, what we're doing is that lowering of these barriers, so that they do not need to resort to the 4 elements that I mentioned before: the regulation principles, the crafted privacy enhancing technologies, or the management tools. Just as a clarification, in this project, the threat model that we address is a honest but reckless engineer. So maybe you could say, okay, but what if the engineer doesn't want to abide or to stick by privacy and data protection, and they want to tweak and chip the system? This is something we are not addressing. What we are addressing is an engineer which is not knowledgeable about privacy, and they are using our tools to supply their lack of expertise, or their lack of resources, or their lack of time, or their lack of money to hire someone which is more expert, but which is honestly and willingly trying to make their system privacy compliant. If they are trying to cheat the system, if they are trying to game our method, this is not something we are addressing. We are addressing risks to the rights and freedoms of the data subject. For sure, companies face risks when dealing with privacy and data protection, but this is not the risk that we are primarily addressing. What we are saying is we'll check for the threats that may affect data subjects, the rights and freedoms of data subjects, not the threat that you may get a liability or a fine and need to pay because the data protection authority tells you that you must pay 4% of your income. It's not that. It's the risk that the identity of your users could be disclosed, or that third party could correlate your data sets with theirs, or that data is not used for the purpose for which it was specified, etc., which in turn protects you from getting fines or getting liabilities. But this is the secondary result, not the direct result. And finally, in our threat model, we consider that the organization itself could be a potential attacker. This may sound a bit strange, but if you think, for instance, in terms of occupational safety and health, it makes a lot of sense. As you may know, in occupational safety and health, the workers need to be protected by the company from the company itself. And the companies need to carry out risk assessments on behalf of the workers, and they need to be protected, and they do so. And you cannot have a worker without a helmet, for instance, if they need to have them. They need to wear them because otherwise you would be violating the occupational safety and health laws. So this is the same, but instead of addressing the workers, this is addressing your users. You just put into your shoes and you decide, or you check whether there's a risk that your organization could be trying to maliciously use the data for things that it wasn't initially expected to do so. Yes, maybe it could be cheaper, maybe you could win more money if you use the data for malicious purposes, and maybe it could be cheaper to have workers not wearing a helmet, but you must do so to protect them on their behalf. And finally, in the approach that we are following, we are trying to stick into the privacy by design principles that I mentioned earlier, and the shift left paradigm. So instead of making privacy something that is addressed at the end, at the right-hand side part of the development lifecycle, once it's under operation and maintenance, and then you solve privacy issues or privacy breaches, we shift that left to the beginning of the software development lifecycle, to the earlier stages, since the requirements, risk assessment, and design and assurance. So this is what we want to do, and then I'm detailing the contributions from these 4 disciplines, and these will be later presented into specific presentations from each of the different tools. So let's start with risk management. In risk management, in this project, is addressed from a multilateral perspective. So we are using Lindun, which is a method already mentioned several times for data protection impact assessment, which is required by GDPR, which we complement with some other risks to rights and freedoms of data subjects, but we also include risks that come from a different method, which is Strike, which is in this case used for security impact assessment. And then we consider also derived business risks. I mentioned before the idea that companies may be at risk for lack of compliance with GDPR, but we are not addressing directly non-compliance risks. Why? Because otherwise we could be incentivizing companies to check whether it's worth it to be whether it's worth to be non-compliant with GDPR. Okay, I'm risking 0.01% fine of 1 million. So yeah, let's not comply with GDPR. No, that's not the approach that we follow. The approach that we follow is disencourage organizations from not complying with GDPR, but showing them how much they could be risking. But we are not carrying out that kind of risk assessment that lets you balance or create a trade-off so that you can decide whether to comply or not. No. Compliance is a must. And if there are risks that are analyzed in terms of uncertainty of what could happen, what if, and they derive a risk for the organization, yeah, we also show that, but this is to discourage non-compliance. And then I said risks that involve uncertainty. Not everything is a risk. For instance, there are some risk approaches that, or so-called risk approaches that say risk of not providing a transparent privacy policy. That's not a risk. This is addressed from a different perspective. You must provide a transparent privacy policy. You cannot say, there's a risk that I didn't do that. Come on, do that. This supports the execution of data protection impact assessments, which basically follows traditional risk management steps, which will be detailed later. But I would like to emphasize that this risk management covers many aspects of GDPR. GDPR is said to be risk-oriented in that it requires you to be proactive in managing risk and not just covering breaches afterwards, after they have happened. And risk management appears in several parts to GDPR, in the famous data protection impact assessment, also regarding security impact assessment. Data protection impact assessment may also involve consultations to data protection authorities. Then when data breaches happen, different measures need to be taken depending on the risk of the results of the data breach. It's not the same if just some non-sensitive data has been disclosed or if it involves larger risks, etc. Second discipline, requirements engineering. Requirements in our case mean what appears here. Privacy goals, I mentioned in the beginning, you remember, confidentiality, integrity, availability, but then also linkability, transparency, and intervenability. Regulations, for instance, GDPR, which includes requirements shaped in different ways as principles, as data service rights, as obligations, as measures, but also requirements may come from standards, for instance, ISO 29100. And we always need to take into account that privacy and data protection requirements need to be taken into account in the context of functional requirements. What does this mean? If I tell you to make a system secure or privacy respectful, or if I tell you to be to have communications encrypted, for instance, to be more concrete, you could ask me, okay, how do I implement that? Because I don't know which communications I need to secure. And this is what means that they need to be in the context of functional requirements. So what we create are requirement templates, indeed, that are instantiated for each project regarding their functional requirements. We use a method which is based on what's called problem frames. And we find successively requirements from abstract principles in a hierarchical taxonomy of requirements, going from abstract principles to detailed requirements. Relation to GDPR, well, I already mentioned that in GDPR requirements appear in different ways as principles, the whole chapter 2, as rights of the data subject, right to forgotten, right to erasure. Chapter 4, obligations of controllers or processors, and the responsibility of the controller. Then there's other parts of GDPR which are also related to requirements and which provide you the parameters for instantiation. For instance, I mentioned for each communication, you must have them encrypted. Imagine that's a requirement. It could be discussed. Then this means that you need to instantiate that for each communication. So this instantiation is for each different nature, scope, context, purpose, lawfulness, and risk of the data processing activities. So for each data processing activity that you have, you need to instantiate the requirements. Then there are some specific requirements in GDPR for specific data categories, for instance, sensitive data, or for specific processing activities, for instance, profiling, activities, marketing activities. Some requirements do not apply to SMEs, etc. And then there can be also some external requirement sources, because GDPR is not completely contained in itself, but it opens the door to further, let's say, regulation, co-regulation, external sources, certifications, for instance, corporate practices. Third discipline, model-driven design. In model-driven design, we have indeed different tools and different steps, and they answer different questions. So first is data mapping and inventory. If you are creating some data, if you are dealing with some personal data, then you need to take into account which data you are dealing with. So that's what data mapping and inventory means. Basically, you need to be aware of which personal data you're dealing with. Architecture analysis and, then enriched models. So the models that you already have, because we are not creating models starting this project, you are expected to be having models. They can be enriched with properties or attributes that relate to personal data from different perspectives, structural, behavior, architecture. Then once you have those models enriched with attributes dealing with personal data, you can analyze them and apply different transformations so that the models of your systems are improved from the privacy data protection perspective. And finally, you can test whether your models stick to this privacy data protection aspect. Relation to GDPR, GDPR does not tell you anything about modeling, but it tells you about mechanisms, about measures, about data protection by design. So there are lots of design concepts that appear here and there throughout GDPR. And then the fourth discipline that we address is assurance, which can be decomposed into these three activities. First, we model the regulatory framework. The regulatory framework in this case is GDPR, but it can also be other regulations or standards. Then once we have this regulatory framework model, that is only done once. This is done once for each framework. If you use this tool in your organization, you will not need to create a regulatory framework model. It will be provided for free or together with the tool, unless you have any industry-specific framework, something like that. And then you start your assurance project in your organization by reusing reusable argumentation models that are also provided by the project or that you create by yourself, and which allow you to demonstrate compliance by capturing evidences that support that compliance, and through some logical argumentations demonstrate that you are abiding by GDPR. This assurance is quite relevant in GDPR because of many principles in GDPR, the principle of transparency and the principle of accountability. In summary, this means demonstrate that you are compliant, be able to demonstrate that you are complying with GDPR. It's not enough to behave well, but you also need to show that you are behaving. And also it can be used for certification purposes, and it needs to take into account all the complexities in GDPR. For instance, when different parties are involved processing personal data, what happens with evidences such as record keeping, what happens when there are data breaches, the evidences that you have dealt with them appropriately, etc. Then the final part of the presentation, how we address everything from a methodological perspective. What we want to create is privacy method engineering that puts everything together, but which is not a monolithic approach, but just a set of tools, a set of methods that you can combine, adapt them to your methodology, and which you can also adapt to further regulations you may want to create. And where we define a set of activities, a set of roles, a set of artifacts that are created and that can be ideally used all together, but they can also be adapted to be used independently if you only want to use one of the tools for one discipline. This is done thanks to a model-driven engineering approach throughout the project. And A model is what you see here. This is a model of a locomotive, an engine, as a constructing miniature working representation of a machine. And this is a model in model-driven engineering parlance. This is a specification which, working in this case, means processable, and which can be shown through diagrams. But a model is much more than a diagram. Modeling is addressed from 4 disciplines, which are the 4 disciplines that we address in the project. I will quickly go through them because you will have time to see them in the different presentations. There are models that are used throughout the project in different disciplines: models of assets, threats and controls in risk management, problem frames and requirements model for requirements engineering. For process assurance and method engineering, there is model reference framework, the arguments, the evidences, documentation patterns. And for the design part, you'll find models from different perspectives: structural, procedural, architectural, and weighted with privacy properties, and which can be transformed according to privacy. This is a summary of the method approach that we follow in all disciplines. This is quite theoretical. I don't want to get into details, but just take into account that there are some parts that are provided by PDP4E and that can be reused, which is some part of a framework. And then you will need to have your system model, your requirements, your functional requirements, your system model, your specific assurance case, and you will be able to transform them, validate them, or assess them through the use of our tools. It's always the same. You have risk threat trees, and you have specifics of your project. You instantiate the risk, you analyze the risk. You have requirements. It's always the same. This figure just wants to show that there are some gaps that are not covered by current tools and which need to be provided by the tools from PDP4E, and which we are addressing in the project. This figure just represents details of the processes that we follow and that you will be able to find in the documentation of the project that is published on the portal. And this presents the approach that we follow in the project and that I would like you to take into account during the rest of the sessions. I have just provided the scaffolds where all the rest of the people from the project will be providing the tools. But take into account that these tools do not create a monolithic tool set, but they are tools that complement each other, same as a wrench complements a hammer. You use them for different purposes at different parts of your do-it-yourself work. In particular, this is a summary of what you will see in the next presentation. You will see risk management tools, which from sets of knowledge bases of threats and controls provide privacy controls that need to be implemented. Requirement tools that provide requirements from meta requirements and specific of the project. Model-driven design tools that provide enriched system models, which can be also analyzed by applying patterns and techniques. And evidences that are gathered from all together and which are used in the assurance framework. That's everything. I think I'm 5 minutes behind the schedule, so I'm